Learn how to drive a car by just sitting in a library reading this massive imagine like trying to learn how to drive a car by just sitting in a library reading this massive 900-page physics textbook on internal combustion engines.
Right, or like thermodynamics.
Exactly. You'd know everything about how the fuel ignites, but I mean, the second you actually got behind the wheel, you'd just crash straight into a mailbox.
Yeah, you'd total the car immediately.
You really would. And look, that is exactly how most people are trying to learn artificial intelligence right now. And honestly, it's exactly why they're failing and just giving up entirely.
Oh, totally. I mean, it is the absolute definition of information overload.
Yeah.
We are dealing with this massive pedagogical crisis right now.
It's just a tidal wave. You open a browser and bam, boot camps, dense math, articles screaming that your job is already obsolete.
Right. People are being handed the keys to literally the most powerful technology of our generation. But those keys are buried under this giant mountain of jargon and conflicting advice and, frankly, just terrible teaching methods.
Teaching methods that prioritize, complex syntax over actual understanding. It's completely overwhelming. But, well, that is exactly why we're doing this deep dive today. So, for everyone listening, we've synthesized a really massive stack of current educational data, course curriculums, and research on the absolute best AI learning pathways for beginners.
And our mission today is really to just tear down that pedagogical wall.
Right. We want to cut through all that noise, bypass the endless scrolling, and basically engineer a structured, psychologically sound pathway, like going from absolute zero knowledge beginner to an advanced builder. Okay, let's unpack this.
Let's do it.
I'm putting myself in the shoes of someone who has zero coding experience. Like, I don't know a Python from a garden snake, but where does the actual day one starting line even need to be?
So you begin with pure concept. I mean, before you even touch a keyboard to write a single line of code, you need to understand the map of the territory.
Okay, pure concept, no code at all.
No code at all.
Yeah.
If we look at the most successful introductory platforms out there, their defining characteristic is actually that they strip the coding away entirely. Like take Elements of AI, for example. This was created by the University of Helsinki, and it's become this massive global phenomenon with over 1.7 million learners.
Wait, 1.7 million? That is literally the population of a small country. Why is it pulling those kinds of massive numbers?
Because it completely lowers the cognitive load. I mean, part one of the course just introduces the absolute fundamentals, what a neural network conceptually does, how machine learning actually differs from traditional programming.
Yeah.
And it does all of this with absolutely zero code.
Right, because traditional programming is, it's rule-based, right?
Exactly. You write the rules, you input the data, and you get an answer out. But machine learning flips that entirely. You input the data and the answers, and the system figures out the rules.
Wow, okay. So by focusing purely on that conceptual shift, Elements of AI makes it accessible to, anyone, even high schoolers.
Exactly. It's incredibly accessible.
So starting here is kind of like learning the traffic laws and, the layout of a new city before you ever try getting behind the wheel of a Formula One car.
That's a perfect analogy. And what's fascinating here is that the initial barrier to entry for AI isn't actually advanced calculus or complex software engineering.
It's not.
No, the barrier is simply vocabulary. Once you understand the terminology, that whole intimidation factor just completely disappears.
That makes a lot of sense. And looking at the sources, Microsoft's AI Learning Hub seems to take a really similar approach, right?
They do. They explicitly separate their curriculums into technical and non-technical paths.
Yeah, I noticed they offer this Azure AI Foundry training, but there's also this huge emphasis on responsible AI principles, and it's all completely free.
Which is so important.
It really seems like a smart move, understanding the deployment and the systemic impact of these models before you learn how to unleash them on the world.
Absolutely. And IBM Skills Build does something really similar for early learners. They've got about 14 hours of free content covering AI basics, how chatbots process language, things like that.
14 hours is a solid chunk of time.
It is. But their unique hook is this tangible reward system. You actually earn digital badges when you finish.
Okay, I have to play devil's advocate on that for a second, though. Do employers or, college admissions boards actually care about a digital badge from a free IBM course? Or is that just, a vanity metric to keep people clicking?
Look, it's a valid skepticism. A basic badge isn't going to magically land you a 6-figure machine learning engineering role at Google.
Right. Obviously not.
But that's not its purpose at all. It's a signaling mechanism.
It's a signaling mechanism.
Yeah, like for a high school student putting it on a common app, or maybe a marketing professional looking to pivot their career, it signals initiative. It proves you understand the vocabulary.
It shows you actually care enough to put in the time.
Exactly. But you are totally right to imply that it's just a starting line. Eventually, you do have to transition from knowing the vocabulary to actually speaking the language.
Right. You have to eventually start driving the car. So, how do we bridge that gap? How do you go from conceptual theory into actual implementation without immediately hitting a brick wall of frustration?
Well, this is where we transition to practice. And honestly, the architecture of the course you choose here matters immensely.
What's a good example of that?
A standout example of doing this right is Google's machine learning crash course. They actually completely overhauled it for 2025 because they realized that just reading about machine learning algorithms is incredibly dry.
Oh, it's the worst. Visualizing it makes all the difference. I noticed their update leans really heavily into animations to show how the math actually changes the data.
Yes. They combine those visual case studies with these great hands-on exercises using TensorFlow.
Okay, wait, let's pause right there. TensorFlow is one of those words that just gets thrown around constantly.
It really does.
Yeah, and it's called an open source machine learning framework. But to a beginner, the word framework is just meaningless jargon. What actually is it?
Okay, think of a framework kind of like a commercial kitchen. If you want to open a restaurant, you don't build the ovens from scratch, right? You don't wire the electricity and install the ventilation yourself.
No, I mean, you just rent a space that already has all that stuff.
Exactly. You rent a commercial space where the heavy-duty infrastructure is already in place, so you can just focus on the cooking.
Ah, okay.
So TensorFlow is basically Google's commercial kitchen for AI. It's this pre-built, heavy-duty software infrastructure that lets you build complex machine learning models without having to write all the underlying foundational math yourself.
That makes total sense. Now, speaking of practical application, Andrew Ng's AI Python for Beginners over at deeplearning.ai is like frequently cited as the gold standard here.
Oh, Andrew Ng is legendary in AI education, and his beginner course works so well because it blends basic Python programming with immediate dopamine-inducing applications.
Dopamine-inducing is a good way to put it.
Right. You aren't just printing Hello World on a blank screen for 3 weeks. Within the first few modules, you're actively building working recipe generators and chatbots.
Okay, but I do have to ask a direct question on behalf of everyone listening who is just dreading all the syntax errors.
Sure.
Do I absolutely have to learn Python to do any of this? Like, can't I just be a really good prompt engineer and tell ChatGPT to just write the code for me?
I mean, you can certainly use prompt engineering to generate code snippets. That's a valid workflow now.
Yeah.
But if your goal is to actually build AI systems, integrate them into software, modify them, and truly understand what's happening under the hood,
Yeah.
then yes, Python is the indispensable tool of the trade. AI models are just overwhelmingly built and trained using Python.
So there's no avoiding it.
Not really. Trying to build AI without it is kind of like trying to write a novel in a language you only know to Google Translate. You're just inevitably going to hit a ceiling.
Got it. So eat your vegetables, learn your Python. Because once you do, it unlocks this massive next tier of education. And one methodology that just constantly pops up in all our research is Fast.ai and their Practical Deep Learning for Coders course.
Yeah, Fast.ai is a slight step up. I mean, it does require some coding background, but their pedagogy is honestly revolutionary.
How so?
Well, traditional computer science education is strictly bottom up. You spend months learning linear algebra, calculus, and basic algorithms before you ever get to actually build a neural network.
Which is why so many people just drop out of boredom.
Exactly. It's exhausting. But Fast.ai, led by Jeremy Howard, flips this entirely. They use a top-down approach.
Top down meaning they just throw you into the deep end immediately.
Think of it more like teaching someone to play baseball. The traditional academic way is to spend 3 weeks studying the physics of a swinging bat and another month memorizing the rule book, all before you're ever allowed to touch a ball.
That sounds awful.
It is. But Fast.ai's top-down method says, here's a bat. We're playing a game today.
I love that.
You play the game first, you strike out, and then you learn the mechanics of the swing to fix your mistakes. From day one, Fast.ai has you writing code to build a collaborative filtering model.
Okay, collaborative filtering, that's basically the underlying logic of recommendation engines, right? Like how Netflix knows to recommend a specific sci fi movie because it analyzes what other users with your exact viewing history have watched.
Precisely. You are building those exact types of systems immediately. You're dealing with natural language processing and computer vision right out of the gate. They prioritize the practical build over theoretical lectures.
Which perfectly transitions us into, well, the pacing of this whole journey. Because now that the learner is actually writing Python and building recommendation engines, how do they structure their ongoing practice?
Right, the day-to-day routine.
Yeah, and our research highlights two vastly different routes here. You've got these quick weekend warrior sprints versus rigorous university-level academic marathons.
And the truth is, both are necessary, but they serve completely different psychological purposes. So let's look at the sprints first. Platforms like Kaggle offer an intro to machine learning micro course that you can literally complete in about 3 hours.
Okay, I really have to push back on that. 3 hours. Can you genuinely learn machine learning in the time it takes to watch like a single long movie? That honestly sounds like a marketing gimmick.
I get why it sounds like that, but it is not a gimmick provided you understand what it's actually teaching you.
Okay, explain.
You are not achieving mastery in 3 hours. You are not going to go architect the next Chat GPT after a Saturday afternoon. But what Kaggle Sprint does is it breaks the psychological barrier.
Right.
It forces you to take a real messy data set, clean it up, and train a basic model. It gives you an immediate win.
So it's mostly about momentum.
Exactly. It's pure momentum. And to maintain that, Katie Nuggets lays out this really cool structure of 7 weekend ML projects.
Oh, I saw that.
Yeah, the strategy is to spend a Saturday building an image recognition model or predicting survival rates on the Titanic based on historical passenger data.
The Titanic beta set is such a classic. It's fascinating. You're basically feeding the algorithm data like passenger class, age, and gender, and the model learns the grim mathematical reality of who was most likely to get a spot on a lifeboat.
Yeah, it's a bit morbid, but it's incredibly effective.
It turns abstract statistics into a literal historical puzzle.
And that tangible connection is what makes the concepts finally stick in your brain. But look, once you've done a few of those sprints, you're inevitably going to realize that you don't truly understand the deep mechanics of the models you're deploying.
Right.
And that is when you need the deep academic marathons.
Right, the marathon runners. Our data points really heavily toward Harvard's CS50 Introduction to AI with Python.
Yes, CS50 is famously rigorous. I mean, this is where you learn the actual heavy lifting. We're talking graph search algorithms, adversarial search, and reinforcement learning.
Let's actually demystify reinforcement learning really quickly because that phrase sounds super intimidating to a beginner.
Sure. Conceptually, it's actually very similar to training a dog.
Go.
You put an AI agent in an environment. If it takes an action that gets it closer to its goal, you give it a mathematical treat, like a positive reward signal. If it makes a mistake, it gets a negative signal.
So trial and error.
Exactly. Over millions of iterations, the AI just learns the optimal behavior to maximize its treats. Harvard's course actually forces you to code these systems from the ground up rather than just using those pre-built tools.
Which is a huge step up. And Microsoft also offers some incredible curriculums in this tier too, right? Like their ML for Beginners track.
Yes, that one is great. It features 26 lessons focused purely on scikit-learn.
And just to clarify the jargon there for you listening, if TensorFlow is the commercial kitchen we talked about earlier, scikit-learn is a Python library, which is kind of more like a massive box of pre-molded Lego pieces.
That's a great analogy.
Yeah, like instead of writing the complex math for a standard regression algorithm completely from scratch, scikit-learn just gives you that specific Lego piece pre-built, and it's ready to just snap right into your code.
It saves so much time. But, perhaps the most universally praised resource for this whole marathon phase is the Dive into Deep Learning Interactive Textbook.
Often just called D2L, right?
Yeah, D2L. It's currently used by over 500 universities globally.
So what makes a textbook so revolutionary? I mean, a textbook is a textbook.
It's the format. It completely rethinks what a textbook can even be.
Yeah.
Instead of just static pages of dense map, every single chapter is written as an executable Jupyter notebook.
Oh, this is such a cool piece of technology. For those who aren't familiar, a Jupyter notebook essentially lets you mix standard formatted text with actual live blocks of Python code all on the exact same page.
Right, so imagine you're reading a paragraph explaining the calculus behind how a neural network learns.
Sure.
And then immediately below that paragraph is a block of live code implementing that exact math. And you can actually change the variables, execute the code right there in your web browser, and instantly watch how the output changes.
That is amazing. It basically turns reading a textbook into a highly engaging, interactive laboratory.
It really does.
Here's where it gets really interesting to me, though. If you look at the structure of everything we've just discussed, the optimal learning path for AI is almost entirely backward from how we traditionally do school.
What do you mean?
Well, normally you read the dense theoretical textbook first,
Okay.
right? Then you take a written test on it, and then maybe like months later you do a practical lab experiment.
Yeah.
But all the data on AI education suggests we should do the exact opposite. We should do the hands-on tinkering, the 3-hour Kaggle sprints, the weekend projects, before we dive into the heavy theoretical deep end.
If we connect this to the bigger picture of cognitive science, it makes perfect sense. I mean, theory is incredibly dry to absorb in a vacuum. If you try to learn matrix calculus on day one, you will quit. But if you've already spent 3 months building chatbots, failing, fixing bugs, playing with data, suddenly that theoretical math has a context.
Great, you actually care about what the math does now.
Exactly. When you hit a wall where simply snapping those scikit-learn Lego pieces together isn't enough to solve your problem, that is when you are truly hungry for the underlying theory.
And that is exactly when it's time to pull out the heavy artillery, the deep theory.
The big guns.
Yeah. We're talking about the Coursera specializations, specifically the Imperial College Mathematics for Machine Learning course. And then there's the big one, the classic.
The deep learning book.
Yes.
Written by Ian Goodfellow, Yoshua Bengio, and Aaron Corville. Bengio is literally one of the godfathers of AI. This book is essentially the foundational text of modern AI theory.
And it's free online, isn't it?
It is available completely for free online, but I will warn you, it is mathematically dense.
Very dense.
But it is exactly what you want to read after you've gained those practical skills, and you want to truly understand the advanced mechanics of what your code is actually doing.
But pushing into advanced mechanics and writing complex code inevitably leads to one thing, right? Your code breaking, the error messages piling up, and you having absolutely no idea why.
Oh, that's just a daily reality.
Right. Which brings us to a really crucial element. You cannot survive this journey without a community lifeline. The whole lone wolf programmer thing is just a complete myth, right?
Absolutely a myth. The idea of the solitary genius typing furiously in a dark basement just isn't how modern software is built.
No.
Modern AI is built on collective intelligence. When you are stuck, community support resources are literally your only way forward. Platforms like GitHub are essential.
Yeah, our research specifically noted GitHub repositories by creators like Dataflare, which offer over 100 beginner-friendly projects with the open source code included.
And the way you use that is by forking the repository, which essentially means you just make a personal copy of their code for yourself.
Okay.
You learn by looking at how someone else built a working system and then deliberately breaking it and modifying their implementation to see what happens.
It's kind of like buying a working toaster at a thrift store, bringing it home, and just taking it apart with a screwdriver just to see how the heating elements connect.
That's a great way to think about it.
Yeah.
And beyond GitHub, you also have resources like Geeks for Geeks. And crucially, the specific AI subreddits and the fast.ai forums.
Those forums are gold.
Those forums are where the actual learning happens. When your model is outputting absolute garbage data and you've stared at the exact same block of Python for 3 hours,
You've all been there.
posting your specific error code on a Reddit ML community or the fast.ai forum is how you get unstuck. Someone else has always encountered your exact problem before.
Always. Which brings us to a really critical pivot point in this deep dive. Because we've just dissected an incredible array of resources, and almost all of them are world-class, and incredibly, almost all of them are free.
Which is amazing.
It is. But there's a catch. Having unlimited access to free information doesn't automatically create a skilled developer. Learning in a vacuum often leads to severe burnout.
It is the single biggest point of failure for self-taught learners.
Yeah?
Motivation wanes.
Yeah.
Having all the information in the world just doesn't matter if you lack the structure to synthesize it or if you don't know how to apply it to a goal that actually matters to your future.
So what does this all mean? Look, having all these free courses is like having access to every ingredient in a Michelin star chef's pantry.
Yeah.
The flour, the spices, the tools, they're all right there.
Yeah.
But without a recipe or like a sous chef to guide your timing, you're probably just going to make a mess and order takeout instead.
Exactly.
You need mentorship to provide the rhythm of the kitchen. And an interesting case study in how to solve this is a cohort-based program we analyze called Better Mind Labs.
Right. Programs like Better Mind Labs operate as a sort of structural overlay. They don't necessarily reinvent the curriculum. Instead, they take all of these fantastic resources we discussed and they provide the guided mentorship and accountability required to tune that abstract knowledge into finished real-world projects.
And the distinction of real-world projects is vital here.
Yeah.
We talked about the Titanic dataset earlier, which is great for a weekend sprint, but you can't put a Titanic tutorial on a professional resume.
No, you really can't.
At a certain point, you have to build things that solve modern problems.
Precisely. And cohort programs focus on actual industries.
Yeah.
Healthcare, finance, sustainability, cybersecurity.
Real stakes.
Yes.
Yeah.
Building a basic stock market forecaster or a tool that analyzes energy consumption data requires a completely different level of engagement. You aren't just doing homework anymore. You are engineering a solution.
Right.
And you are doing it in 4 to 8 week flexible cohorts, which, actually mimics the agile development cycles used in the real tech industry.
And it solves that vacuum problem because you are forced into pure collaboration. You have to exchange ideas, defend your code to your peers, and network. There's also the very pragmatic element of how this translates to career or academic advancement.
The output has to be tangible. If a student builds a functional stock forecasting AI, that needs to be communicated to a college admissions board or a hiring manager.
Right. Otherwise, what's the point?
Exactly. Structured mentorship programs usually provide mechanisms to showcase these projects effectively, whether that's on a common app, a polished GitHub portfolio, or through direct recommendation letters from the mentors who oversaw the code.
And for anyone wondering, yes, programs like this are designed even for absolute beginners with no coding background.
Okay, we have covered a massive amount of pedagogical ground today. From stripping away the code entirely, to visualizing the math, to embracing the backward learning path of tinkering before theory.
It's a lot to take in.
It really is. Let's bring it all together for everyone. If you were to synthesize everything we've analyzed into a single, cohesive timeline for the listener, what is the optimal roadmap?
Okay, based on the data, the most effective roadmap is broken into 3 distinct phases. Phase 1 is the conceptual foundation, spanning roughly months 0 to 3. You are a complete beginner here.
Okay, months 0 to 3.
Your focus is strictly on elements of AI to learn the vocabulary, the Google ML crash course to visualize the math, and Katie Nugget's weekend projects to get some quick psychological wins using simple data sets.
Got it. Months 0 to 3, grasp the concepts, get some quick wins.
Phase 2 is the builder phase, covering months 3 through 6. This is where you embrace the top-down approach. You take Andrew Ng's AI Python for beginners to learn the syntax, and then you dive right into fast.ai.
So this is where it gets real.
Very real. You gaggle, even if you don't fully understand the underlying calculus yet.
Months 3 to 6, top-down building, getting messy with Python. Finally, phase 3 is the architect phase, month 6 and beyond. Now that you know how to build the systems, you seek out the deep theory to understand why they work.
The marathon.
The marathon. You tackle the mathematics and the deep learning Coursera specializations. You challenge yourself with Harvard's CS50 AI, and you finally open the Goodfella Deep Learning book. That is a comprehensive, battle-tested path from zero to advanced architect.
When we started this deep dive, we talked about that feeling of trying to learn to drive by reading a dense physics textbook. But looking at this roadmap, the pedagogical fog really does lift. You don't have to be a math prodigy to start. You just need to follow the right psychological steps.
It really is entirely doable if you structure it right.
It is. But as we wrap up, I want to leave you listening with a completely different thought to chew on. We've just spent this entire deep dive giving you the ultimate roadmap to learn how to write the code that trains artificial intelligence. But right now, the frontier of AI research is actually focused on training models to write their own code, debug their own errors, and essentially train themselves.
It's a wild time.
It really is. So the real question isn't just how you learn AI today. It's this. The keys to the most powerful technology in human history are sitting right in front of you, entirely accessible and often completely free. The only remaining question is, what are you going to build with them before they start building themselves? Something to think about. Until next time.